The bag contains 21 raffle tickets, 16 of which are white, 4 are yellow and 1 is blue. 2 raffle tickets are drawn at random without replacement from the bag. Calculate the probability that at least 1 white raffle ticket is drawn. Okay, so this time it's a bit different to the first question, isn't it? Because in the first question it was exactly, they said exactly 1 black marble, if I remember rightly. So here though, it's at least 1 white raffle ticket. So let's just think about the possibilities here for this. So the first one could be white, but then the second one would not be white. Okay, so that would work, wouldn't it? At least one of them white. Or the first one might not be white. Okay, so if it's not white, remember we put a bar above it, and that would be the yellow and purple essentially. Okay, these would represent the yellow and purple. So the first one's not white, but the second one then would be white. But there's also a third possibility, and that would be both of them are white. Okay, they both could be white, and that sort of meets that criteria, doesn't it? Now we've got 3 calculations to work out here, and that's quite time consuming. So we could think of an alternative approach. And if you think about it, this actually accounts for most of the situations. Okay, almost all. The only situation I haven't counted here is them both being not white. Okay, that's the only other situation here that's missing, them both being not white. But if you sort of refer back to this here, if it's at least one of them white, well, it's going to be this top line here. The only case that doesn't apply is this here. So what we could do, we could actually do less work and simply focus on working this out, calculating that, where you consider the situation that you don't want, where white doesn't come up at all, and then once you've got that probability, just simply take it away from 1. Take it away from 1, and then you can work out then what the answer is for all of this up here. Okay, so it's a backwards way of doing it, but it's much quicker. So let's just start off by defining how many white we've got. So we've got 16 white, and of course they're not white would be the yellow and purple put together, so that would be 5. So if I just work out that there, probability not white, not white. Okay, so we're not getting white to start with, so that would be 5 chances out of 21. And we're not getting white for the second pick. So remember now that means then there's only 4 left, because I've already taken one of the yellows or purples out. So there's only 4 left, and of course out of 20. So if I work that out, that would be 20 there. Okay, and 21 times 2 is 42, and add a 0. Okay, so we've got 20 over 420. And then it's quite simply, this is the case that we don't want, isn't it? We do not want this situation where there's no whites at all. That's the case that we don't want. We want every other case, but we just do not want this. So essentially there's 20 options out of 420 we don't want, so we just need to see how many options we do want, and it's going to be the rest. So the probability of at least 1 white will be equal to 1 take away the probability that we don't want, this option here. So it'll be 1 take away 20 over 420. And remember, 1 represents everything. Okay, so 1 can be written as 420 over 420. So we're left with 400 over 420. And they do ask in this case, they don't usually ask, but they do ask in this case to simplify. So if we simplify this, of course, we can divide top and bottom by 10, so the zeros disappear. We can halve top and bottom, so we get 20 over 21.